Hello everyone. Today we will going to see the next toolbar in Pal design, that is dress up features. So this dress up feature toolbar consists of different commands, that is fillet, chamfer, draft, shale, thickness, tap or threading, and remove face. So let's see one by one. To perform the dress up features in a 3D, we required simply a 3D model. So let's draw a 3D model. I will draw a simple rectangle over here, giving its dimension. Its length is 100 and its height is 50. Exit workbench. Now provide the additional thickness or simply padding. I'm putting the padding of 50. Say okay. So this is my 3D model. Now let's see each command one by one. So first one is fillet, that is edge fillet. Select this one. Select the edge one by one. Now see, if I apply a preview, the radius is 5 and selected element is 2, the first one and second one. If I apply preview, we get the edge fillet. Now suppose if you want the edge fillet to entire this face, so rather than selecting each edge one by one, you directly select the face. How? I will show you. Now suppose if you want to delete any one of the edge, so in that case click over here, select the edge that you want to remove and select and remove. So in this way we can simply remove it. Okay, I will show you how to use this edge fillet to entire face. So I'm selecting this, radius is 5. Okay, I will increase it and say okay. So in this way we can use the edge fillet. If you want to different edges, here one, here you can go. Otherwise if you want an entire face edge, then select the same. Now the next one is the variable fillet. The variable fillet itself indicate that the fillet with a different radius. Okay, so how? Let's see. I'm selecting the first one, I'm selecting the second one. Now see over here, if I zooming this one, here you find something is written over here. This is radius R, radius R. If I double click over here, so the value is 5 mm. If you want, you can change it, that is 10. Okay, here again double click. If you want, you can change to 2. Say okay and say preview, say okay. Now in this way you can come up with the variable fillet. In the previous case that option was not there. That option is only to get the uniform fillet. Okay, after this the next part is chamfer. Again in chamfer we have two types. The first one is length chamfer and second one is length and angle chamfer. Let's see. Here is a length and angle chamfer and length. For length and angle we require the length and angle. If I am selecting this one, if I increasing its length and say preview, now see, in this way we get the length and angle chamfer. If you want, you can change the angle. Okay, similarly for the length one, you require the two length. One is above the edge and below the edge is second. You see, okay, in this way we get the variable chamfer length from this particular edge, 13 and 11. Okay, now the next part is simply a draft. Selecting this as a draft. Here the draft angle is 5 degree. If you want, you can change it. Okay, now here face to draft. Select the faces which you want to draft. Okay, I want to draft all this 4 faces, so I'm selecting one by one. 1, 2, 3 and 4. Okay, 4 element got selected. The next is neutral element. It's having a 0 reactions. It is neutral. Now see, I want this is neutral. So when I'm applying these things, see what happened. Preview. Now see, entire view gets changed except this top face, because the top face is subjected to a neutral element. Say okay. Now see how it perform. So that is use of draft. If I reverse the direction, if I change the direction, see what happened. This is exactly the reverse. So in this way you can make use of this particular draft. The next one is a shell command. So for the shell command, you select the face and apply the thicknesses. Say okay. Now see, in this way we can perform the shell operation. Next is thickness. Thickness means providing the additional thickness to my part. Okay, now I'm selecting this face to whom I want to increase the thickness. If I'm increasing its thickness value, see, it is going on increasing. So in this way we can use this command to increase the thickness of the component. That's it. Okay, the next part is simply a threading. So to understand this particular threading, I'm drawing a simple solid cylinder. So before that I'm simply deleting all these things. How to delete? In a variable, and the right click on this particular one, say delete, or simply drag this one. See, delete. Okay, and come up with the simple circle. I'm giving a dimension to it as a 10 mm diameter. Okay, applying a pad, reverse direction. Okay, now I'm giving it's the external thread. So select this one. Here we have option of thread and tab. The thread is for external and the tab is for internal. This is a simple image. It shows us a lateral and the limit. So lateral face I am selecting this one, and the limit face I am selecting this particular top face. Okay, now here we have the metric thin, metric thick and non-standard. You select as per your requirement. When I'm selecting a metric thin pitch, again we have a different varieties, but for this particular one we have only a two varieties, because the outer diameter is 10 mm, so it is applicable for first and second only. Okay, if you want you can increase the thread depth. Say okay. So in this way we can apply an external threading to my component or to my object. The major drawback of this CATIA is comes over here, that is this system is unable to show the thread on the particular component. So to understand this one we have to go in a drafting, so where we simply find its thread. How? I will show you quickly. I'm going to here, drafting. It is for you just understand how it look like. I will cover the drafting part later on. Okay, now see, I'll show you in the right view. Now see, here you find the threading, right? So that is one of the limitation of the CATIA. Okay, the next part after the external threading is internal threading. So I'm using the same solid cylinder but providing a simply hole over here. So I'm selecting this top face and go here hole option, going into the positioning sketch. Okay, so this center, if it is not, then you can make this particular point exactly at the center of this circle. Okay, exit a workbench. Now I'm giving a diameter of 5 and depth is 50 and say OK. Now see, this is the hole in a solid cylinder. Now go for this tap. Lateral face is this one and the limit face is this one. Now see, here if you want you can go with a non-standard, or if you want you can go with the standard one. So this 5 is standard. I'm selecting the 6 and I'm increasing its depth. Okay, say OK. In this way you can come up with here the internal threading. Let's see how it looks like. Now see, this is look like this one. This is simply the internal threading. The previous was on the top side, the current one is inner side. It is called as the internal threading. So that is the major limitation the CATIA is having. Okay, thank you.